this is the first time. And thank you everyone for braving this harsh weather and coming for this meetup. It's really pleasure meeting you, all of you in this meetup. So, okay, so this is the topic of my today's talk, selecting the right DB. Just now I got a improvement opportunity in this, like it could have been a better word, like selecting the right data store. I think that would have been a better thing to mention here. So, why I selected this DB, sorry, this topic. So, okay, so what is the need to know different type of DB types or data store types? So, in today's world, we are working mostly like applications are moving towards from monoliths to microservices, and microservices, it's very difficult to keep a single DB type or data store type for microservice there, because there could be a single point of failure. So there would be requirements for different type of data stores in a microservice for a single application itself, and it becomes quite a paradox of choice for data engineers and architects to choose to select what kind of DB shall we go ahead with. Like there are lots of DBs to select from, or lots of data store types to select from in today's technology environment. So this is the topic which I would be scratching around. It's not a deep dive to any of the DBs, and I hope with this talk or with this discussion you would be able to at least gauge your data store, what is the direction you want to go ahead with. So along the other thing is like each DB or data store comes with its own benefits and trade-offs. So while doing a selection for any specific DB or data store, you have to be conscious about the trade-offs and benefits. It should not be like we should be only knowing about the benefits of that specific DB. We should also be knowing about the trade-offs, because once we select a DB and we are continuing with our journey, and later in the stage of development we got to know about some trade-off, it becomes quite difficult to move back to our decision and revert the things. So this topic or this discussion will help you to make up the decision as well. So there is a question for the audience here. What are the criteria do you think, right criteria, or what are criteria in your mind do you think would be there?
It is relational. So the first criteria should be relational or non-relational. Right?
Yeah, that is the first criteria.
SQL or no SQL.
Which is the most popular DB in the market? Marketability.
Yes. Marketability, yeah.
Reliability,
Performance.
volume,
Performance,
yeah.
performance.
Read and write ratio.
Exactly.
Non-functional requirement, NFR.
I'm sorry.
NFR.
Exactly. This could be
The data model. Yeah.
data modeling. Yeah, I think people know most of the topics which I'm covering here. So, yeah.
It's a document or graph.
Yes,
Depends on topology.
Yeah. So,
Do you have people who can work with that?
exactly.
Yeah, that's the
So first thing is ease of learning curve. How easy or difficult for the people who are working on the project to grasp the technology. How fast they can pick it up and they can start implementing on that specific database which we have selected for our project. Other one is ease of data modeling. What is data modeling really?
I know a schema.
Exactly. So it's like kind of how easily we can model our classes, or how easily we can replicate our classes into the DB structure, and how easily we can have a reference also amongst our tables which we have in our classes as well. So how easy or difficult that part is to implement in the DB, that is the other criteria. Scalability, throughput. How easy or difficult it is to achieve these two things, because in today's scenarios, unless and until you are not working on a legacy code or some old application. Most of the applications which we develop today, we keep these two things primarily in our mind, that our application should be easily scalable and it should be able to provide us the required throughput at the time when we need it. Again, the fourth one is availability and partition tolerance. It comes out of the CAP theorem, which I think most of us would be aware about here. So how, though it is in general words, I would say this is the last thing which we should think about, to go for partitioning and all those stuff. Because doing that in the initial stages means that we are doing something wrong. This would be in the end of our project, or project when nothing works, or like all of the things we have taken account of, and that is the last criteria I would suggest to go for, is partition tolerance. And consistency, as all of you has mentioned, this is the basic criteria to meet, which we should look into, like is it, do we need ACID transactions or base transactions? What are base transactions?
Basically available.
Sorry?
Yeah. Base is like you got ACID for relational database. Base is for NoSQL database.
Okay.
And base availability and eventual consistency, and they talk about other two are not able to.
Yeah, basic availability, soft consistency, and eventual consistency. So that is about consistency. Other thing is programming language support. So if we have selected a database which doesn't support the framework of our choice, it becomes quite difficult to implement in for our project. So that is one more thing. And this is the last one, read-write priority. I think someone mentioned. This is also a very good criteria which we should keep in our mind while selecting the DB.
And another criteria is like volume, the size of data,
Yeah.
as well as the distributed. Don't you think is required, whether it is required to have a distributed or not? If it is small app, I can go with a small database.
Actually, yeah, most of the DBs, I think they don't care more about volume. Most of the DBs today support even SQL. If we have very strong relation, or we strongly need SQL and we have high consistency, and we have still high volume, SQL is not a bad choice. Like MySQL or MS SQL, it's still not a bad choice.
Let's say for enterprise application, we have to think about distributed data, right? So, maybe cluster of
distributed, it again depends, like you need only distributed data or you need any other criteria along with them. If you need only distributed data, definitely the SQL would not be a good choice for that. You can go with any of the cloud providers or any of the NoSQL. Like there are multiple choices in NoSQL database also, which we will be discussing going forward. So
Nowadays, you are having this realm offline database, like it does not need to be connected in the mobile. Like realm database, it can work offline also. It does not need internet connections. Then online and offline database also you want to take criteria?
yes, that could also be one of the criteria. Like if you are dealing, like one of the good example of offline DB which can handle good amount of volume of data and it provides very high latency. I don't know if you have heard about SQLite.
Yeah,
Yeah, SQLite is a very good example where it could handle decent amount of volumes. It can't handle like good or very high volumes, but with decent amount of volumes and with cache and all those stuff, SQLite would be a good option. Though it is not online, it is offline kind of stuff. Okay, so one more question. What are the different type of databases you can think of? Apart from like transactional database, MySQL, SQL Server.
Time series.
time series database.
Column
Document data.
Graph database, graph,
Key value database.
key value database, caching, column, yep. So these are one of some of the databases which I will be discussing based on these criteria. So first our favorite database is relational database. Example of that are Oracle, SQL Server, Postgres. So what is the ease of learning for this? It is, everyone knows a relational database from their, I would say, college days or from their basic projects. So it's quite easy to learn, it's quite easy to implement, it's quite easy to write queries on that, but it becomes quite difficult to handle transactions. We need some knowledge to handle transactions for this relational database. If transactions are not handled, and that is the main purpose we go for relational database, if those are not handled properly, it can cause some issues. And ease of data modeling, it's quite easy to data model our classes and our relationships in the from our model to the database. And next one is scalability and throughput. It's quite tricky to handle scalability and throughput in the relational database, though it can be done with some effort. But if you are looking for like a distributed kind of or partition tolerance in relational database, I would say these should not be the best choice to go ahead with. And the other one is consistency. The consistency provided by relational database is better than all other databases which we will be discussing. So I would say if you want to go with relational database, if you want consistency and ease of data modeling as well as programming language support. All the programming or frameworks, most of them support relational database, be it .NET, Java or whatever programming language you want to go ahead with. And read-write priority, so basically it's not a binary choice, like it should be read or it should be write only. So it's kind of put it as a scale. So it would be, is it inclining toward read or is it inclining toward write? So relational database, they handle both of these scenarios quite well, like read as well as write priority. So the next one is key value database. So these are the type of database which works on the principle of hashing. Like we would be providing a key and we should be able to get a value out of it. They don't understand modeling. What goes inside, what type of data type they are working with, what is the relation they are working on. It's none of their business. They just store a key and they just retrieve the value out of them. Ease of learning is not very high learning curve for this type of database as well. Some of the examples for this are Redis, DynamoDB. So scalability and throughput, they are known for their scalability as well as throughput. So since they can be scaled across horizontally across many instances, and so that is the one reason these are mostly used for caching purpose and all. So apart from that, partition tolerance is also very good for these type of databases. They don't work with consistency. Like they are very bad if you want to go ahead with, if you want to have a consistent application. Key value database, it's not actually made for that. It's made for storing the, one of the purpose I can think of is to store the cache. Programming language support, again, they have a good amount of they mostly support most of the programming languages and frameworks which we have. And out of read and write priority, they would be giving more inclined toward reads. Like we want to fetch some data quickly out of some, for some key value, it would be very easy to retrieve out of these type of databases.
Just one question now. Does this DB support SQL kind of interface?
No, no, no.
It does.
They won't support. Though they are like they are improving on like DynamoDB and all. They try to include some SQL query type of things, but again there would be some learning curve for that you need to.
Okay, one more thing is, can we store some objects say, as a value, like maybe not a huge object, but say, it's because it's a cache, right? So cache can also be
Yes,
an
yes,
object,
yeah.
right?
Yeah.
So,
We can store blob. We can store it as a blob in this type of DB. It can be. I don't know how huge you want to put
not
it
a
across.
huge, but yeah, because see, cache should not be huge, right? Maybe some small object. You have-
Small, it works even with medium type of like. I don't know what would be the criteria, but it deals with the even fairly objects with even good amount of size.
You can build key value stores to support different data sizes as well. At LinkedIn, we had blob store, we had Redis, proprietary tools as well. So even with this for size, we had custom built key value stores.
So if you see in the Redis, they have instead of a key value pair, they have a hash rate. You can
Sure.
So I have used it now, Redis. So for the performance of like if some key is called, like I need to have like some set of JSON. So that one you can implement Redis something called hash rate. With that you can utilize it. Yeah. I think the options are there. And DynamoDB also will help you on that. It's like way you architect the data. You can keep like if I need a username, key value is a password, you can have it in the simple format. Or the value should be like something kind of hashed or like something encrypted. You can have that. It's like you define it.
It can be any data. So hash rate is just an example, but it can be any data structure.
Yeah, it can be anything. I think they answering the question, they officially support few data type structures, so you can follow their documentations. I think we moved from key value to hash rate, lot of concepts.
Or by DynamoDB or
No, I'm talking about Redis.
Redis.
Yeah.
So KB databases are basically hash map on steroids, and I think Redis is byte safe, so you can store any data. You have to evaluate others separately. Redis is byte safe, so you can store anything in Redis, and you can store, retrieve, parse it, and it will be intact. But that doesn't
byte safe. It is like secure.
Yeah, I know. If it's byte safe, it can store blobs, it can store images, video, audio, anything. It doesn't matter. But you can't assume that guarantee for other KB databases. You have to verify through documentation.
So the next one is again NoSQL. So basically these are all NoSQL type of databases, key value, DynamoDB, and next couple of DBs which I will be discussing. So okay, so document database are the database which deals with the document kind of DB. It could be JSON or XML. So there are various applications which directly stores or retrieves the JSON values or JSON documents into the DB, and they deal with that itself. Like I don't know, an example could be if I'm planning to store my structure of my website as it is as a JSON document in a DB database. That could be one example, and while retrieving I would display the structure by retrieving that JSON from the DB and display as it is on the website. This could be one example of use of DocumentDB. Any other examples? No, any utilizations of
So most of the time your user activity data where you don't know what a user A and a user B might differ their data structure or their data pattern, you would usually use a document DB where you don't know the end JSON structure itself. So like website is a good example. You have a B2B application where your customers can define their profile structures. You would usually end up storing that onto a document where for a user X and a user Y, their structures could look completely different because of the profile types they chose. So that would usually be this.
So again, ease of learning curve is it's not very, it doesn't need much of your time to learn these kind of DBs. Data modeling also, it's kind of there, yeah, we can model our classes or our relationship. Like now these days, some of the databases, they are trying to improve on their data modeling capabilities, which are of document database type. Scalability and throughput, it is of not very high, like they won't provide you very high scalability and throughput. Availability and partition tolerance is again of fair amount. They are not consistent at all, they won't be providing any consistency. Programming language support is again fair, and again retry priority. They incline mostly toward reading the data more than writing the database values. So that is document database. Some of the examples are MongoDB, which is very commonly used across projects, and another one is CouchDB. So
MongoDB would be more consistency and partition tolerance, not more availability. Because that is structured in a single writer and replication data, the cluster equipment, etc. So that's why it's a more consistency with the partition tolerance and availability is there.
yeah, I think okay. So it can't be made highly available, that's what you are saying.
Yes.
Okay.
No, so the data model is independent of availability function choices. It can be a highly available document store, or it can be a consistent data store. It is not tied to the document model itself. It may vary between MongoDB and CouchDB and other databases.
Okay. So the next one is column family database. And what are column family databases? Why do we need them? Any answers?
Like giving an example, BigQuery is a columnar database where each column has been indexed by default. So that you can query on whatever field you want. So mostly this columnar database we use for analytical purpose. So giving example, BigQuery is one of the columnar database where each column is indexed by default, where you can query from any table you want, and it's mainly used for the analytics purposes.
So basically, if we are dealing with, as we mostly deal with relational database, if you want to, suppose if you want a value of some particular column, so in that case also we provide a query like select all from, select some first name from the maybe customer table where something condition. So in that case also it would be doing a table scan for that specific column for that specific condition which we have put. So column family databases removes that problem. So basically, as my friend has mentioned, they index they create basically the key is the column name and value is the values of that specific column. So it won't be doing a whole table scan if you want to retrieve the values for that specific column. It's mostly used for data warehouse capabilities, and that's the one utilization I can think of where we need to retrieve the values of columns from a huge database, and it could be quite difficult in other scenarios, but it would be very helpful, this type of column family databases. So the ease of learning curve, it's quite, we need some effort, we need to put some effort to learn these type of databases if we are coming from traditional relational databases. Data modeling, it is, as you can say that it is not at all supported in data modeling for column family databases. Scalability and throughput and partition tolerance is good for these type of databases. they are not made for consistency, they are not at all consistent while for their transactions. Programming language support is also very bad. They can't be used with normal programming languages and frameworks. They have their own utilization that they can be used for reports or while to generate reports using Excel and all. It would be very difficult if you want to implement them using some programming language or framework. Read-write priority, it inclines mostly toward write, since it becomes easier to, like there are cases where we want what I would say, data warehouse kind of capability in our application to generate the reports. In that case, we migrate our data from relational database to our SQL database. Maybe it could be with the help of jobs and all. So it becomes easy for the relational databases to write into these. So this is one of the reasons these are more write intensive. So the next one is graph databases, and some of the examples are Neo4j, Infinite Graph, and where are they used? Like graph databases, in normal relational databases, we have to find a relation bit, or like we have to reference table using some reference key amongst the tables. But that is not the case in graph databases. There would be a edge between two data points which would be denoting the relation between these data points. So it becomes quite easy to fetch the data from these type of databases instead of going for a normal relational database where we have to do multiple join among tables to fetch the data. And these kind of databases are mostly used in what I would say, these applications, social media and all.
Recommendation.
Yes, exactly. And LinkedIn, I think, use this kind of.
Netflix.
Telecom network.
Okay, telecom could be one of these. I was not aware of that. So, ease of learning, it's definitely not easy to learn how to implement those. I was trying to implement Neo4j for a small sample application in my project. But it was quite high, like I have to learn lots of things to do that. Ease of data modeling also, you won't be able to visualize by looking at the data, like how these classes are derived from this data. It won't be easy to visualize from the data which is presented in these type of databases. Scalability, throughput, availability and partition tolerance, they are fairly good in those areas. Consistency model also they provide. Like they are some of that, like Neo4j provides consistency. As I was experimenting with that, it provides a good level of consistency support and all those stuff. Programming language support and framework is again not very good for these type of databases, and read-write priority is mostly inclined toward reading of data. I missed that read and write. So it's quite easy to read data from these type of databases, like using the queries, and since we don't have to do relationships or using references, so it becomes quite easy to read the data. And next one is new SQL. Anyone heard about it? What are these?
I heard about Cocktail. Very important.
So what?
Got a lot of promotional emails for CockroachDB, but never really realized what it is.
What it is, exactly. So what is new SQL? Any rough idea by looking into this?
Scalable SQL basically.
So it came around, I think, 15 or 16. It's not that much old. So it is mix of both SQL as well as no SQL, as we can see from these criteria. So it's quite easy to learn. most of them would be implement using the SQL queries for implementation. It's same as to create tables and all those stuffs as well. And it's quite easy to have a relationship or references among tables in this type of DBs. Yeah, as someone mentioned, we keep getting promotional mails from DB. It is one of the example of new SQL type of DB. And ease of data modeling again. So it's kind of mix of, it has taken best parts from SQLDB and no SQLDB, as you can see from these criteria. There's no need to mention these here. And if we are like in the nascent stages of implementation of our project and we need best of both worlds, this could be a good choice to
I have got a question on this. Like SQL database, you have got a row based, and no SQL database, you have got a column based. When you say no SQL database, which type it is having? Row, column based, or nothing based?
No, this is not NoSQL. All of these are column family, document, key value,
Yes.
and all of them were NoSQL.
Yeah, a column family. But when you say this new SQL database, it is which family? Row family, column family?
It's
or
not.
which?
It's the best of both of them.
Best of it, then how can you design?
No. So,
Like you have got a man and woman, and in between that you have got in human beings also. Then in similar way, which way you design that part?
row and column databases are defined from the perspective of how they're stored on the disk. New SQL databases are predominantly memory databases. There's
Memory
below-
database also you need a place to, just you, anything you need to write a place to write.
The
It
place,
cannot write anywhere.
it is placed in memory. They
The
use
memory means
constant-
RAM. Then RAM also you need some way to design that storage part. How
Yeah.
you need to store there?
I don't think they're meant to be column databases. I think to
It's a
apply
relational database.
I think they're row based.
Okay.
It is relational database, transactions, OLTP, everything is same. It is SQL database improved, like a next generation SQL.
Then you say that it can follow the cap theorem and
Yes.
acid and base theorem, all the
Yes,
part.
it is exactly, yeah. It is a relational database. It exactly
Then
same
it
like a
cannot
relational.
follow the base theorem.
Base
Just
theorem.
a relational database follow the acid part, and base and NoSQL database follow the base part.
This is not NoSQL. Let's make that clear.
Yeah.
This is not NoSQL.
Yes.
SQL
This
with
is
better
relational.
availability and
It is a
partition.
relational database with improvements in the underlying architecture which make it little bit more scalable.
Yeah. My question is
That-
that when you say architecture, which way? Like row based, column based, or which way
No, it's
architecture?
relational only. It's relational only. How
No,
they store
relational
underlying.
is row based.
Row based, it's row based.
Yes, row based, of course.
I can take that.
So,
So
relational.
they are meant to be OLTP databases. They're not meant for OLAP use cases. New SQL they provide consistency, they provide ACID, they provide high read write, but they're meant for short-lived, fast transactions, OLTP use cases.
Yeah, it's row based.
Can you,
It's like it's
okay, can you give some industry which companies is using or which sectors are using this PBS?
new SQL.
Yeah, this one.
I am sorry, I can come up, maybe I can post in that Meetup group. I am not very familiar which industries are using, but like currently if you are starting with new projects and all, and if you want to get best out of both worlds, I think this would be,
Yeah. Because today we heard about, at least myself, I never gone through this.
So OLTP is designed by Stonebreaker. Stonebreaker is considered the father of databases. He's a Turing Award winner. So in terms of the theory part, I doubt you can beat him. But again, it's not, there is no single database which solves all problems. It is meant for a very precise set of requirements. I assume the trade-off is for durability. I don't know how durable the data is.
okay. So the next one is cloud native databases. These are some of the databases which are provided by individual cloud providers, and they have
I
their
just
own.
from the last slide I got one more question. In new SQL, it using SQL or it is having different
SQL,
language?
SQL only.
At least whole DB is SQL, I'm not sure.
Cockroach DB, I was also looking about the documentation, it also uses SQL, so I think most of them would be in the same, since they are in the same family, they would be.
Yeah,
using.
sure.
So next one is cloud native databases, and these are the databases provided by individual cloud providers. Each and every cloud provider, they have their own database families, like Amazon has DynamoDB and Redshift, and Azure has also like Cosmos DB or something like that. So each and every cloud provider have their own native databases. And these are some of the criteria like ease of learning curve. There will be a fair amount of learning you need to do to learn about their APIs and all that stuff. Data modeling is not that much good. Since these are backed by well-known cloud providers, scalability and throughput is fairly good, availability and partition tolerance is also fairly good. Consistency, like when they started developing some of these databases, it was not supported, but eventually they are improving from the consistency point of view. As far as I know about some of the AWS databases, they are improving on their consistency mechanism. And programming language support also, I would say, is fairly good. They support most of the frameworks and programming languages. Read-write priority is more inclined if you want to do more read intensive queries or related operations. They are mostly used for these kind of purposes.
Underlying, they use one of the existing databases, or they have written their own database.
Redshift does, I'm not sure about Snowflake.
Okay. So Redshift is like its own database. It's like separate from
Redshift is built on top of, was built on top of Postgres.
DynamoDB is, I think they have developed from on their own.
Okay.
It's not built on.
Okay. So it's not DynamoDB is not like a layer on SQL or
Redshift is under the Postgres only.
yeah.
Sorry?
Redshift is under
Yeah, that's
Postgres
right.
only. No, it's scalable.
It is implemented by Postgres, but Postgres is a row data store. So I think Redshift is
Column.
It's mostly used for data warehouse.
Yeah, data warehousing purposes.
So it's mostly column. So I think this is the last one, time series database. These were one of the databases which are used most frequently these days to support IoT devices and many other purposes, like they store basically each and every activity done at a timestamp. Like when we are running in a marathon, we are provided with a beep and all those stuff. So that beep stores the position of that runner at each and every timestamp. So this is one of the examples. So these are basically used to store the data points and at each and every timestamp. So they have to be the amount of data stored in these databases is quite high, and it's not very easy to learn these kind of databases. And data modeling is not there since they support only timestamp kind of data structure. So we can't expect any data modeling or references coming out of these databases. They are highly scalable. The throughput is also very good since they deal with a huge amount of data and very frequent amount of data, so scalability and throughput is also good. Partition tolerance is mentioned as very low, so consistency is also fairly enough. I don't know why I mentioned consistency as fairly enough. It should not be, they are not made for consistency. This could be a mistake from my side. Programming language support is okayish, like fairly they support mostly known frameworks and programming languages they support, and they are mostly meant for read instead of write.
I was thinking it is mostly for writes than reads, because it's the amount of data that it
Yeah, these two
gets
things
in
things
is very
are
high.
mixed up with.
Actually, time series databases is used for a lot of analytics. You want to do trends.
That's correct, but that's you will do only once in a while.
No.
But in here, but the amount of data that it gets is very huge.
So when we are doing a time series trend, right? For example, we are doing the stock analysis. We want to switch from what's a daily trend versus weekly versus monthly at the click of a button.
Correct.
So which means that you're doing a lot of transactions, and you need to be able to process that. You don't want to wait for 5 minutes to switch from a weekly view to a monthly view.
Okay.
Right? So it's primarily for the analytics purposes.
So it could be in between also, like it could be for read also, it does like quite fair amount of data it reads from each and every point. It's quite read intensive queries and all it would be. And as you mentioned, it could be like we put lots of amount of data at each and every second or maybe millisecond, so it could be write intensive also.
It is write heavy. I mean, it's optimized for fast and high amount of writes. The design philosophy is that if you are doing analytics using time series DB, it's okay for a chart unless you want to find out what happened in the past hour. You know, that can come up, that can take time to come up. No, that can take time to come up. But if you are registering events at the rate of millions of events per second, time series should support that. It's okay if you can see millions of events in 5 minutes or 10 minutes. It's okay to take. A very nice example is any cloud providers monitoring dashboard, right? It shows what happened over time, right? Shows the event diagram. That's typically backed by time series DB. So you should, like, if an event happens at 10, 1 a.m. and 1 second, 1 millisecond, you should write it quickly. It's okay, you can read it later and it can be slow, but they are optimized for writes. This is what I was trying to say.
So in that case, for stock market, where you need to see the current trend, like immediate trend, like what has happened at this point of time, who has bought the stock and all, what's the price at that point of time. So that may not be able to use this.
Nobody says that you can use only one type of DB. You will have different use cases. You want fast write also, you want fast read within a short window also. At that time you can't use only one database. You might need different types of database. So these are just, I mean, if you understand what use cases is supported by each, nobody is saying that you should, ideally if you have a complex product, you will use multiple types of databases. Right? If you have an OLAP, analytics is separate, you have time series events which is separate, relational queries are separate, everything has its own purpose. Right? So stock market use cases, you can split those two use cases and use different databases. It depends on the query pattern and the criticality of the requirement.
So similar to CAP theorem, we call run congestion, read, update and memory. So the congestion is that you cannot optimize for readability, updatability and memory efficiency. In theory, as long as you're ready to throw money at the problem, you can do both R and U. But it is not efficient to do all three. So you can do one of the two out of three. So if you had enough memory, if you had enough money to throw at the problem, you can have a time series which is both good at reading, good at writing, which is true for everything.
What are the again? Please mention three.
Read, update and memory.
memory.
Okay, so these are some of the examples of DB types which I have discussed in this.
Coming back to the previous slide, let's say, take it like this way. When I see cloud native has all the same stars, okay, except the easy of learning. So how do I make it decision making? When should I use cloud native or when should I use time series? So with perspective.
Cloud time series has its own unique problem which it solves.
Right.
We
Cloud native
How do
are
I make
hosted,
differentiate?
hosted services.
Hmm.
So you can you can have a MySQL hosted on the cloud.
Hmm.
You can have Cassandra hosted on the cloud. So go to the next slide. The last one. So things like relational, key value, document, graph, these are based upon the data model. NewSQL is relational but using memory. Cloud native can be any of this, but it is managed by some cloud provider. So basically, there are multiple things being condensed in this slide.
Okay.
Cloud native, again, they could have like each and every cloud provider have their own implementation of database as well. Like that DynamoDB is a good example from AWS. And I think Cosmos, as I mentioned, from Azure. So these are their own native databases which each and every cloud provider provides.
Okay, coming to specific now, the same question. Let's say I will take the cloud native Amazon Redshift. Another one time series I am going to take Amazon time stream. So between those two, how do I make it? Both are having similar features.
No.
Or let's say,
Okay, the number of features are many.
right.
Data model, which is independent from asset choices, which are independent from cap choices, which are independent from RUM choices,
Okay.
and cost, the programming languages of support, how familiar are the people with it. There's so many dimensions. So it's like you have N into M into P into Q into, it's a huge sample space.
And you
Yeah,
mentioned
here-
something like RUM or
RUM
what is that?
is the database tailored for reads, optimized for reads,
Okay.
or updates, or memory. If you can throw in enough money, you can do it for both reads and updates, but you're paying paying for memory.
So first you need to define your purpose, what you want to achieve.
The
Then you
Q
have
is
to-
in the name, right? Time series. If your data is it changes with time.
time, yeah, data
Time
points.
is a component of your data structure. This is a very, very small use case actually. The rest are more generic.
Time stream is like, as Anu mentioned, it's very specific use case. Others we need time and energy to decide which database we need to. Like Redshift is again a specific use case. It's used for data warehouse purposes. And it's mostly column based DB.
I think his point was cloud native. So I think cloud native, right? So cloud native in the sense, whatever cloud native principles are, based on that, those cloud vendor has created their own databases. They are offering. That can fall under relational as well, non-relational as well. But here he has categorized, given a category that cloud native, and in that category he has included more those databases which are more suitable for data warehousing. So I think Snowflake's DynamoDB, right? And Redshift, there are Databricks cloud offering also. It is more towards analytics and all. So here cloud native and the offering he has mentioned more towards big data kind of databases. But cloud native, it is not exactly what example he has given, but cloud native we can understand in a way that those databases where cloud provider has built, optimized for cloud, it can fall under relational, non-relational, and other graph as well and time series as well. But it has been built in a mind that it will be get offered from cloud. Nowadays, every database offering are moving, aligning towards cloud because they have to anyhow offer from cloud nowadays. Yeah. So I think that was your dilemma to understand it, right? Yeah.
Thank you.
Thank you, Rakesh. So these are some of the references. First reference is a very good book, Software Architecture, the Hard Parts. This book basically deals about if you want to break up a monolithic architecture into a microservice architecture. So what are the challenges you can face and how you can overcome these challenges. It's a very nice book, I would recommend. Most of the stuff I have taken from that book. And others are these YouTube channels. This is a new SQL link which would be very useful. It's a good talk which I found in YouTube. Yeah, so that was all about this talk. Any other questions?
My question is related to the reality how we are using the database. So I have a database on the legacy system. So when I enter into the projects or something new item, how do I know this database has been utilized in the right way? So there may be multiple components might be linked to the database. Like example, SQL, they have multiple tables. But how do I continuously monitor? Are I using right way the DB or I'm not using the right way? So I can go with an example. In the code base, if there is any error, I have something called the error tracking system or like code analysis. So I can say like this code is a very bad batsman and error tracking, the exceptions are not handled in a proper way. So this is how I manage in the code. How do I do? Is there any supports or services there? Like how we can keep on continuously monitoring and doing the right way in the team.
So I would say this is quite a learning process, and most of the DB, whether it is cloud native or maybe provided by individual company, each and every database provide their own monitoring solutions. Like in this SQL, Microsoft SQL, we have query profilers and we can use those scanning diagrams and what is the amount of data or what is the input it is being used to process some particular stored procedure. All this stuff mostly, like I have mostly worked on DynamoDB and SQL, so they provide their own monitoring solutions. I am sure that other cloud providers or DB providers should be providing their monitoring solution. If we can go with out of the box monitoring solutions, there could be other monitoring solutions like Grafana. We can use.
Yeah, I have used Grafana, seeing the analysis. I have practically problems to see the analysis, whenever the system I use for background task, to see the data, like time series kind of stuff, to see like the system is up, tasks are getting executed probably or not. Yeah, that's how I use Grafana. One case, what I do is like data, because it's like who is creating the application, they can put the data there how they want. They may not be following the principles, but they just put the data how they want. At some point of time, we might figure out this is the way the architecture is wrong, completely wrong. Because I can go with an e-commerce application, there are already proved schema is there. But when I go into the application of legacy system, right, the schema, whatever the proved or schema for orders and everything, that will be there, but they won't follow this one. They put it in a very different way, very easy way to access the data. But when it comes to scaling, it blocks. So at the time we noticed, okay, it's not the right way. Someone in Stack Overflow already shared, who is like SAP or some legend, like who have done it in the right way. So that's a way it'll take more learning to compare all these things. Something like this is the way this data monitoring or the error tracking something will be helpful.
Usually your query profilers will also, so a general use case is read and write. That's most of it. So if you are wanting to read a particular row or a document, how much you end up scanning for it usually would give you the data that you've probably not indexed it right, or your data, you're reading too much to get too little. You require 3 data rows and you're reading 30,000. You usually know that your structure is somewhere wrong. So that would help you profile your data. There are ways where you can query profile. I don't know exactly how, but you can query profile at a smaller data set and you can extrapolate that at a large scaled data store, what will happen to the same query. So those usually would help you identify whether you get a right
I think
structure.
first of all, you should be thinking of your monitoring posture. Right? What you would like to monitor? You would like to monitor the queries, or you would like to monitor the whole system is up and running when it will come, how was utilization, right? Or you want to monitor and diagnose internals of it. So I think there will be only three questions. One is query size, one is my system health, how much it is heavily utilized, and what is its insight. For example, backup has been triggered on time or not. What are the internals of it? So for three areas, I think for query, he has already rated provider and query metric analysis you can do. For the system performance, I think cloud provider or wherever you are hosting, you will be able to monitor that capability. What is its utilization, security, and all those. For example, I think every databases give you the options, diagnostics. So you have to enable that, but it will slow down in production for a time for some reason, and you will be landing up with storing somewhere and then looking. I think in this way you can have a good monitor, 360 degree.
I have one question. Once you select a wrong database, it is not easy to get out of it, right?
Yes. That's what we have to discuss and come up with trade-offs and benefits at the initial stages of product only. Once we carry on and once we started and we moved with the database, it becomes quite difficult. It's not like that we can't do, but it becomes quite difficult to revert our choice and go ahead with some other thing. So that's what we should be well informed to take a decision based on our knowledge or discussions. And it should be a quite open discussion by selecting this type of things.
Is there any criteria to migrate from one database to another? For example, I have a Oracle database. I plan to move to different database. Is there any criteria or standard format to migrate from one database to another database?
So one criteria, like in this example, you are migrating from SQL to some other. So one criteria which I can think of is the reason you selected Oracle is because you wanted good amount of data modeling, consistency, and all those things. So you would be looking those things in your other DB as well. And so again, you have to look like what are the other DBs which are there in market, which provide these your basic requirements. Apart from that, some more improved features which they have in there. Like you can go with any cloud provider, like they can provide scalability, throughput, and partition tolerance along with your basic requirements. So these are some of the things which you can.
Yeah, another thing is, when you said migration, need not be completely migration. You can do like
Bits and pieces.
from TVs or something. Relevant application perspective, I can migrate it. Have the old for something else. Let's say it may be initially might be adding it. As we said, time series or cloud or something else, we had moved there. This requirement perspective, we can pull out those database and store it in new database.
That is a
rather than migrating completely, right? That's
so when we are moving from monolith is basically we are depending on one database. Now we are moving to microservice. So we would be keeping that database as our primary, but we have to see like what parts we can move out of that single database and what parts we can keep there, which serves the original purpose. And so it's kind of R&D kind of stuff we have to do on our original database.
This migration is another topic.
Yes.
It's like there are few things in your software architecture that
Thank you.
once you decide, very hard to change. Database is first of all, because you have to deal with versioning, migration, you have to deal with customer data and in product. There are crazy parameters that you have to take into account. And it's a multi-month effort. So that is why, in choosing database, your theoretical computer science knowledge comes very handy because nobody tells you, there is no tool that will tell you, oh, okay, this is what you want to do, choose this database. Nothing. So your understanding of what goes into a database, your theoretical knowledge, that comes in handy. Once you choose, you're stuck with it for at least medium term. Long term, I mean, we don't know, but it's not like, let's change from Go to C++ or something like that. It's very hard.
Thanks. Evolutionary process.
Yeah, but when you started choosing, you have got different parameters. Like you see, anything you have got a matrix for choosing the database. And each organization has each different use case when I want to develop. For my B2B business or like share market, then I have got different parameter and like somewhere my latency or constancy. Then based on that, we need to decide.
See,
it is not that very hard that we cannot choose the data. Like you have to need to, what are the different parameters you are looking for. On the basis of that, you go forward and choose the data.
Agreed, but the parameters that force you to change a database are not common. I mean, they don't change so frequently.
Yeah,
they shouldn't. If they are changing frequently, then database is not the right place.
Yeah, it cannot, just see, when you decide, it is not that you decide in a day. It is not that I just given like a toffee you decide. You take a time, you have a discussion with your group, and after that you do it. It is not that like toffee you can decide like a chocolate.
Earlier it was, I think maybe 10 or 15 years it was very easy to pick a time.
Because there were no options.
Exactly.
We have to go for that. But now that we are getting options.
No options is actually easier.
Yeah, that is true.
And there were not many business scenarios as well. Now
yes.
We have to deal with each and everything when deciding with DB and architecture. So it's quite complicated. And I have just crashed it. It can go like, it could be a whole day topic to discuss. So
yeah, that is true.
Like for analytics purpose, so in that write operation,
it gives you more freedom to. That is a point. Why should I look down when I look? If the sky is not having any limit, then why should I look that?
Aggregating to a large set.
So what about like real-time analytics? So in that case, what should we choose?
Apache Flink.
you can just visualize like, I want to do analytics on my previous data, past day, past month and all. So there would be a job running, midnight job, which would be Aram doing this import into the job. So it would be, write is not a problem. It would be read intensive. You have to pull huge reports and all, show the data to the management or whatever. But it needs to be read intensive.
Apache Flink.
What was that? Apache Flink or?
Apache Pino. Flink is also one of
Flink is for event-driven.
like we can have real-time dashboarding over Flink systems. I don't know.
So Apache Pino is like column-based database or
Analytics would be complicated.
because write operation is then heavy if it is a column-based database. Every address is like different if it is a column.
Yeah.
So for example, there is 10 field. So 10 field is address is in different places. If it is row, then like it is just a sequence. So write is easy for them. But it is for column, it is I think it is.
Write is more, it's heavy.
Right,
So-
right. So I understand it very well. Because we learned columnar database is optimized for write. Right? Like Cassandra. Right?
Cassandra is not a columnar database. Columnar is in the context of relational stuff. So relational databases is a columnar made for analytical polar use cases. I don't remember the architecture of Apache Pino to answer, but
From the Cassandra as a columnar database.
Cassandra we learned columnar, right?
Columnar is used only in the context of relation databases. Okay.
I think that's where you got your question coming up, right? Because we learned columnar is more optimized for writing.
No, sorry. So most databases can be classified under the use of trees or mem tables. Again, we can spend a day on this and still don't know it.
Okay, let's stop here. It's a good topic to discuss during lunch. Okay, so let's do that. So lunch is okay before that. Sorry, Vikram, thanks for doing this for us.